Welcome to Drafting and Design Center. Today I will talk about use of civil site design for a road design, in particular vertical profile alignment. Civil site design is add-on software and I have provided the link in the description below how to access demo software for 30 days in a free. So after modeling the intersection, the teen surface is shown. This is how it looks like using civil site design. Today I will talk about how profile of the horizontal alignment shall be created in a civil site design. So once you download the software in a Civil 3D, it will have a populated tabs of gridding, roads, pipe, data share, general, and Atlas Heclas. To create a profile view in a Civil 3D using civil site design, or to create a profile design of the horizontal alignment, once you download that and you click road tab here, we firstly use active drawing setting, which is about giving input for this add-on software, that what is a VC is horizontal curve, vertical curve. Then number two is we use what exactly we want to create. We need to define the cross section. So creation of cross section, it is like a template in a Civil 3D. Number three is to create a profile view using a vertical gridding editor. Number four is using edit command in here to create a surface. Number six is creating a teen surface, and number five is creating a curve written alignment and profile. So I will at the end of this presentation I will just quickly demonstrate the use of all of this. So this is how the profile is being created. As you can see that a vertical grading editor, which is I have numbered it here as number 3, and this is vertical grading editor. You can add the minimum and maximum length of vertical curve and k value using the rectangular tab, clicking this tab and putting input into that. The rest is function associated with the editing of the profile and 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 zooming in, zooming out, and this one is creating a variation into the profile. So once we click in here, we can able to see the k values for crest, sag, and minimum profile, minimum grade and maximum grade. And once we create that entire model, that entire cross sections, we can export teen surface into the Civil 3D. So before going into the software, I would like to go to some of the Australian standard of geometric guide to road design, geometric design. 8, vertical alignment. Here it says the grade requirement and the reduction in the speed. So try not to have a grade more than 9%. Desirable maximum length per grade. is provided here. Minimum grade is for drainage. At least desirable is 1% grade is required. The second is the side distance. Side distance, as we know that the car is coming on a curve or on a straight section or on a vertical curve, it requires distance to perceive the object, react it, and stop it. So this side distance is defined as driver sees the object and the height of the driver is 1.1 meter, object height is 0.2 meter, and he perceives the object, reacts it, and stops before it hits any object. According with a road design guideline, Austrian road design, stopping side distance is based on a reaction perception time and deceleration of the vehicle. These are the two component, and for example, if I'm designing urban road, 50 speed limit, it has a based on a reaction time, the stopping side distance is 48 to 62. Ideally, if you choose to have 2.0 as a standard reaction and perception time for your design, you can have maximum side distance of 55. Is good to have the length of the curve shall be minimum of 55 if possible, or greater than that. This table 8.6 in a road design uh, defines operating speed of 50, minimum length of vertical curve is 30 to 40, and the k value for appearance point of view. Here it defines for object height of 1.1 meter, table 8.7, and uh, eye height of 1.1 meter, object height of 0.2 meter. For 50k speed, the required k value is from 5.2 to 6.8. So if we select our 2.0 perception time, 6.8 is k value for crest curve is required. Set curve, the table is provided for 50k design. If I'm designing for 50k speed limit, based on that low standard road, we not create go in this section. We go for urban and rural road with a street lighting. So the value of k is about to be 7. So about say 10 is a bit higher than what required. 10 uh, require value for k in set curve. And sometimes if you provide length of the curve, so side distance, for example, side distance required is the one we discussed earlier, based on a side distance required earlier, which is for reaction time 2.055. If you have chosen to have length of curve, let's say 50, which is side distance is 55, greater than the length. So in this case, in this scenario, you have to calculate the k value, which is slightly higher than what minimum value required from the graph. So before we just end up this, I will demonstrate how to use this civil site design road tool. So as you can see that I have created a entire subdivision, the roads, and it has the contour you can see is a surface. So if I just go in a, for example, this curve or this alignment, this is a, it is quite slow as you can see that it is a evaluation software. be with me, it is a bit slow here. So it's quite running slow as I have other programs open, and the GB storage is quite smaller. Okay, so once you click vertical grading editor, I have already created a profile of this alignment. So if I click in here, it says select alignment, and once you click there, it will open up the surface profile view of this alignment. As you can see, it is still slow. So this is how it has already created a profile, and if I see the cross section, I can right click here, and this is the cross section of that chainage, which is at 6 meter. I can keep scrolling and see the cross sections. So it is in a cut. As you can see, the yellow line represents this area, which is in slightly cut and fill both at a crown, and so once you scroll down here further, you can see the yellow line will shift, and it has in here it is uh, representing the profile is in fill, the ground is in green. So that's you can able to visualize the profile cross section, and you can able to see exactly the uh, where exactly that drop down arrow is from the. So it will have this is, you can see here, this is the chainages. So it will give you all profile view. This chainage cross section looks like this one, and the profile is here. So for particular of this one, I have a length of vertical curve which is 15 meter, and as per the presentation earlier, you can easily say that length of a sec curve was 15, and uh, for 50k speed require about k value is 7, and side distance, which is the length of the curve from the side distance, is about 55 meter. So for the sec curve of that, you can see that this is under designed. Again here it is not properly designed. Again 30 meter curves doesn't design properly. Again we need to look the length of curve of this one as well, crest curve. For 15 meter, I can add the length or key value by just edit IP. We can click an IP here. It will then have a key value of 2.3, requires 7. So we can try to fit it in. If that fit in, it will allow itself, and it will increase the length of vertical curve by, you can see now is 7 is the minimum we have used, 45. Ideally we use 80, and if we 5.6 is quite very small value, so we can delete this by delete IP, and then we can delete this IP, and then you can see that it has gone. Similarly, we need to look at it 30 meter length, and 25 meter length of the vertical curve. respective k value. By clicking here, you can able to see the k value itself calculated. So edit IP, and once you click 30 meter in here, it will then give you the k value of about 7. This is a crest curve going up the 50k speed criteria. 50k speed. Yeah, so that side distance is 55 is required. Minimum appearance point of view, minimum length of curve is 40, which is okay. Minimum k value is about 7, so it was about 7, so it was sort of desirable minimum value. We can increase it to about 55, which is obviously good practice to go up to the more than side distance if you can able to accommodate it. So then you can able to change it using edit IP. You can move the IP by using, as you can see in the screen here, you can move the IP up and down, and that way the road is increase in fill and cut. The one in yellow color, it shows you cut and fill value, and chainage is here. These are the elevation in the pink, and yellow is again uh, uh, yellow is again up hierarchy up, which is in a cut and fill value. So once, so I will just delete. It is slow there. I would like to show you how exactly I can model this road so that you can have a clear idea. It's worth trying if you want to use this kit. So for example, this road is created. I can delete this road. So delete. Once you click here, it will then given you a box. So I'm sure that it is number 2 road. I can click delete, and delete selected. So as you can see that it has gone. So starting from beginning, the first step is selecting, going in a road cross section, and then selecting the cross section, which cross section of the road. It's just asking me to deselect the curb and return. It's just asking me whether I want to delete the curb. So this is a cross section. It is already inbuilt local metric road 6.0 meter, which I wanted. You can able to put the value in and able to generate this template. You can use this if you want to add different cross section, better condition, left side you can able to add it, and then similarly right side you can able to edit the values. So once I wanna use, for example, local metric road 6.0 meter template, once you create template, say okay, so that it will be saved into that system. So I have to delete this curve written first to be able to show you how exactly. So then delete. So now yes, it has deleted from here. I want to delete this one, so again I have to hit delete. It is this one, it is selected. So you can see that it has gone completely. You can see still the surface is there, which is I need to update the surface, which is can go in a modeling and surface manager. Toggle display. I just don't want to see the surface, so this one. Okay. So now you can see that it has deleted and I have alignment. I want to create an intersection here. So once you have cross section created, then we can go to the vertical grading editor and click on this alignment, which is here, and then continue using this as a road. And then I'm using 6.0 meter template of cross section which I created earlier. Surface is EG. As soon as you hit OK, it will create a surface by itself. We need to make sure about the length of the curve, which I shown you how to edit earlier. Right now I'm just saying OK. So I'm just closing this. So as you can see that my road has been modeled, and I need to create a curve button. To create a curve button which is going into the here, auto curve button, or maybe curve button, you can select it. 10 meter is the default radius I'm using right now. Let's slope it here. So I click on both sides. So the alignment was created and the curve button was created as well. So you then I can able to show you again in a vertical profile. So now as you can see, this is the profile, and here which is in which is at, so that's in green one here. Next, this one, you can see this cursor which is located in here. The cross section is look like this one, which is in a cut. This is in a cut, and if you okay with the grading criteria of vertical curve and other uh, guidelines, you can able to create a surface by going into the toggle display, then create a contour, mesh and contour. Okay, so you can see that the mesh and the contour surface is being created. You can able to export this surface in a Civil 3D by using Civil 3D surfaces. It will be a bit slow. I can do the process here. However, it is slow due to the system is very slow. So once you have surface exported into Civil 3D, it will come up in here, and you can able to use the surface in Civil 3D too. So in this short session, we looked at the criteria of vertical grading, as well as how we use cell site design software to create the vertical profile. You can able to visit the website of this company, uh, which is provided in the description below. And don't forget to subscribe our channel for other updates. Thank you very much.